This is chapter 15, using the schedule to forecast and balance resources. The objectives of this lecture is to create resource relationships, forecast and balance the cash flow, use this thing called a progress S curve and a banana curve. Specifically, we will learn how to create those and forecast and balance these resources, such as equipment, money, manpower, things like that, any resource. So this is a type of process that uses the CPM schedule to manage any resource that you may have. This is an excellent tool for manufacturing, construction, or any process where you're concerned about resources such as the amount of money you're spending per given amount of time, per day, per week, per month, the amount of people you have at your disposal, certain managers, certain builders, certain operators, and uh, pieces of equipment that you may have available to your use, or even specific materials that you have available to your use so that you don't over consume them and such that you have an adequate supply. So this is one advantage of the CPM schedule over other scheduling methods, is to provide this opportunity to balance these resources and sort of predict and forecast them to ensure that you have a proper amount before you start a project. So to do this, you first examine the float. This will help you to forecast and move things around within your schedule such that you don't use a certain amount of resource or overspend if it's cash related. So you would do that by delaying certain activities that have float, moving the schedule around. And then the project team can then be balanced to level out these specific resources such that you're not over consuming them. So generally, we'll see that the float in the schedule and understanding the types of float, the free float, the shared float, and independent float can be a bigger tool than the schedule itself when you're actually forecasting things that you have at your disposal. So the real first thing to do to create this is to link these resources to the schedule. And so to create these resource relationships. So you first need to identify what resource you want to manage and forecast. So that could, like I said earlier, it could be cash, people, equipment, materials. You need to figure out how much material or people or whatever resource that is and link it to an individual activity. And so to create this relationship amongst the individual activities within the schedule. So then the team usually determines durations based on the available resources you have, like we talked about in the determining durations schedule. But you need to also, when building the schedule, notice that the quality relationships need to be considered as well. So you may have accidentally produced a schedule without really thinking through about how it links to actual resources. For instance, you may have certain activities that require the same pieces of equipment. Well, if they're scheduled to happen at the same time, well, that piece of equipment can't be in two places at the same time, or you have to rent another one or buy another one, and so you'll have to reassess your schedule to assess that situation. And so by doing that, you're effectively ensuring these quality relationships between the individual activities. Then you need to consider safety relationships, like we talked about with balancing safety, cost, and quality in the first lecture of this class. So you need to make sure that the schedule is limited to people working over the top of each other or too close to each other that would create some sort of unsafe work environment. Then you could finally, at that point, assess the relationships and link them to the individual activities. And like I previously said, two activities need the same piece of equipment. That a manager needs to determine which activities go first or second, and which one has the priority over the other regarding using that equipment. Or is it more beneficial time-wise to rent or purchase another piece of that equipment? Sometimes it's not as easy as that when the piece of equipment you're talking about is in the hundreds or 200,000s of dollars, and that would eat into the company's bottom line. So we're going to start taking all of that together and put that into an example with working off of this completed schedule. We see the critical path goes right through the middle, YB, YU, S, it takes 19 days, assuming weeks or months, to complete this schedule. We have some shared float up here between KF and O, and also some shared float up here between P and L. So that's going to be the main tool that we're going to use to manage things if there's any resource problems with dealing with this specific schedule we're working on. Again, it doesn't really matter what the individual activities are for this specific example. We're just going to call them with the letters YB, UYS, KFO, and P and L. So now we need to create that resource relationship. In this example, you're working for an excavation company and you're meeting with the manager team to develop that schedule. The durations in this case is actually in months. So I go back and look, see all these numbers, they relate to months. So it's a big project where an individual activity could take upwards to 6 months to complete for Y, for instance. So half a year would take Y to complete in this instance. So it's a big excavation type project. You're confident that this duration logic is good. So slightly what I was talking about earlier, where you need to reassess and you need to move things around to determine that we're good with the logic for now. Then we're going to assign the resource that we're going to forecast to it, and then we may reassess things. But for now, we're confident that the durations and logic look good. What we're trying to figure out and forecast and do is to determine if this project has enough equipment available. Specifically, we're talking about T10 D8 caterpillars. If you're not sure what that is, go ahead and Google it. If not, if you don't care, just think of it as a piece of equipment, a large excavation type of equipment. It's a rather large piece of equipment that's in the hundreds of $1,000s range probably. And also, the owner is very concerned about the cash flow, so we're going to use the same schedule to balance two different pieces of equipment that we have available at our disposal, 10 of these pieces of equipment, and the owner is concerned about funding the project. They can only fund or finance up to $110,000 per month. So individual month, they can only give us $110,000 to work with. So we can't charge any more than that because they can't pay us any more than that. So both perspectives, we need to manage this project and use this tool. We're learning to do so. But the owner wants to know in advance what the monthly individual payments are going to be. This owner probably has other projects that they're financing and concerned about, and they want to know every step of the way what sort of month am I going to be charged. So to do this, you need to tie the resources to the project activities like I've been talking about up to now. So doing this will enable the schedule and the project manager to provide management team with the ability to forecast and control this equipment and cost, these two resources. So effectively controlling any of these resources. For now, we're specifically looking at equipment and cost. Like I said in previous slides, these typical resources concerned are equipment, cost, materials, and workers. Those are the primary things that you would probably forecast, but it's not limited to any of those. As long as you can link them to the activity, you can forecast virtually any resource in a project. Okay, so when we're considering cost in this type of tool, it's generally referred to as a cost-loaded or value-loaded type schedule or forecast schedule. So someone may refer to, can you produce a cost-loaded or a value-loaded schedule? And this is what we'll be doing. The cost-loaded schedule, in order to forecast cash flow, is obviously related to amount of money being spent, and the total amount of the contractor's bid becomes a project budget once the contract is then finally awarded. Then all of the individual activities' value should be equal to the project budget. So you take that and then divide that amongst individual activities and link those together. So that's effectively what we've done, the next step in this example. So you've estimated this through. You've seen that we've listed all the activities here, and we know the total value of the project, and we know that we could divide that into each individual activity. The estimating part of it has figured this out, that W will cost $45,000, activity K will cost 12, B 192, and so forth. We know the individual durations based off of the schedule before of how long each activity takes. Then we can just divide those two numbers into themselves to figure out the monthly value. So W costs $22,500 per month. K is $12,000 per month, and so forth. So we figured all of those out, and this is that process I'm discussing where I've linked the activities to the cost. Okay, so in order to forecast this monthly cash flow, I need to determine the monthly value, which is what we just did. And here's the equation for that. The estimated total activity value divided by the duration equaled the monthly value. That was pretty straightforward and evident on the last slide. So then the next step in this forecasting is to create a bar chart which shows float based on the logic diagram. So we just previously learned this a few chapters ago on how you take the CPM network-based schedule and break that and to convert that into a bar chart for specific people. So then the next step would be after that is to then load the bar chart with the monthly value of each activity. What that specifically means to load the bar chart is to literally just write these numbers, the 22.5, the 12, the 48, on the bar itself. In the bar chart that you just created, we created a bar chart based off of this schedule. On the bar itself, we're going to write 22.5, 12, 48, 36. I'm just rounding these into thousands. So I do 57.5K, 48.2K, and so forth. That's what I mean by load the bar chart with the monthly value. It's just literally write it on it. And we'll see that here in this next slide. This is actually the final answer of what we're trying to do. So I'll walk you through this entire process. The first step I just talked about. This bottom part I didn't talk about yet on that slide. But this top part, the first step I said to make the bar chart based off of that CPM schedule, which I did. We went through that process that we discussed a few chapters ago, where we figured out the order of the activity, W's first, K, then B, then P, and so forth, based off of the duration and the float. I showed float by the little line. So K has 3 days of float, B has 0, P has 1, 2, 3, 4, 5, 6, 7, 8 days of float, which we could also see and extract from the CPM network schedule. Then I've created that, and then like I said, I've loaded it by literally just writing the monthly amount on the bar chart per individual bar. W has 2 cells for its bar, representing a duration of 2 months, and it costs $22,500 per month. So I literally just wrote 22.5 on each cell, 22.5 here and 22.5 here. K costs $12,000 a month, so I wrote 12. B costs $48,000 a month, so I wrote 48 here, 48 here, 48 here, 40 here, and so forth. So notice it's always equal the same value per cell, 48, 48, 57.5, and so forth. That's what these two lines say. Now the next thing that's not written on that slide that says what to do is below the bar chart. I just created a row here that's just the total per month, total in thousands per month. So in month 1, W is the only activity that's happening, and it costs 22.5 a month. So that would just be 22.5, which is effectively 22.5 plus nothing, 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 nothing all the way down. Then that's the same for month 2. W is the only thing that happens in month 2. So that's also 22.5. It changes in month 3. K happens, B happens, and P happens. They each have their own individual cost per month. So 12 plus 48 plus 36.1 is 96.1. And so forth. 48 plus 36.1 plus 48 is 132.1, and so forth. This is just basically the total of everything above it. Okay, where an empty cell is 0. That's it. Then the next thing is I created this, what is called a histogram down here, or just like a vertical looking bar chart. It's all this portion down here at the bottom, which just plots these numbers per month. And see, it coincides with the month still, since it's right on top of right below the bar chart. So this is still month 1, the column that goes all the way through. This is still month 2, the column goes all the way through, and so forth. And then this is just a plot of these numbers. And then here's the axis on the left side starting at 0K. So 22.5K is just this line that comes up to about 22.5, and it remains constant for the first 2 months. Then it jumps up to 96.1 and it's constant for that month. Then it jumps up to 132, it's constant for month 4, constant for month 5, jumps up to 141, and so forth, and just continues along that path, which just plots these numbers. And that's it. This is called a histogram or resource profile showing the cost per month. Now remember, the management team or the owner wants to know from the management team how much are we going to be spending per month, because they could only finance $110,000 per month. So this is what we would tell them. And also we would tell them that, well, based off of our schedule now, we have an issue on month 4, 5, and 6. We are going over that 110,000 per month. Well, a question that always comes up is, well, okay, we're well under the $110,000 month 1 and month 2 and just a little shy of month 3. Well, can we just take some of that money and put it over here? Well, that's not really the question. They could only finance up to 110,000 per month, and they might have money going other places when we're not sure. So we're only just going to charge them 22.5 per month, assuming this schedule takes into our account our profits and so forth. We're only going to charge them for 22.5, and they might use that money, this remaining money elsewhere at that time. So when month 4 comes along, we can't charge them 132.1 because we're told ahead of time in the contract they can only finance up to 110. So we would have to take in that difference, that 22.1 difference here, month 4 and month 5 and more in month 6. So that's a problem. Obviously, we don't want to have to fund our project and then eat into our profits for those 3 days. So this is this process where we would forecast these resources and see if there's any issues like this. So here's one issue with our cash loaded diagram. We exceeded that maximum value. By the way, this was just drawn in here as a bold line to show across the board what our threshold is, our maximum threshold. So I just drawn that in to see. These next few slides kind of walks through a little bit of what I've just said and walks through solutions to dealing with this. So like I said, the resource profile below that is called a histogram. It's showing the cost in a chart form to help visualize and analyze the data. Like I said, the owner can guarantee to finance the project up to the 110,000 per month, so we can see there's trouble in 4, 5, and 6. So attempting to solve this problem, the first thing we'll do, like I said at the beginning of this lecture, is to focus on the activities with float. If we focus on the activities with float, we don't have to rearrange any of the activities. If float doesn't solve the problem, then you have to actually manipulate the activities, where they're positioned, where the predecessors and successors are, then redo the CPM logic, recalculate the float, and sort of start all over. But we first start by focusing on the float. And here's where understanding the free float, independent float, and shared float comes into play. Because remember, shared float has a drastic impact on other activities that are sharing float in that string path type thing that we talked about. Because if we just give all float to the first activity, that then makes the next activities critical. So that's crucial to understanding this, because manipulating the float is going to help us solve this problem. So area P has 6 months of independent float and 2 months that are shared with L. So then if we choose to start area P 5 months late on month 8, so that it would be after O, which would then make O a predecessor, area P would finish on month 11 and still have 3 months of float. So that's one possible solution, but however, going through that motion, that would take away almost all the float from area K, F, and O, which is an example of what I just said. So that was one solution. However, it takes away float from 3 activities, making those critical. And remember, critical activities need to start and finish at the exact same time, have no wiggle room, and then you're going to sort of set yourself up for the possibility of error by creating more critical activities. So another option would be to delay the start of area F until area P is finished. So the area F and O share those 10 months of float. Here's what is happening in the second option for us visually. F is being moved to start on month 7 instead of month 4. And here we go with my cursor. So previously it was at 4 and 5. It was starting now at 7 and 8. Then we also are moving O to start afterwards on month 9 and 10. And then if this was automated, then that would automatically recalculate our histogram down here, which I have the final result here for you, and you can see that it's not above the 110 maximum level anymore. And in fact, it's about 100. It's about 10,000 below that, or so, give or take. And that actually gives us a little bit of room just in case there's any errors in our calculations, or if there anything breaks down and we have to get it fixed, and then that might eat into that. So it gives us a little bit of flexibility in the cost here, actually, by solving that. So this is the best solution for this. It doesn't take away a lot of float, and it doesn't create any additional critical activities. So this is the solution to the first example of balancing the cash, creating a cash flow diagram and balancing cash for this project. And then we went through the process of solving any errors that came about, and then so we met that condition. And this is basically it. So you could see how we've used the CPM diagram, created a bar chart from it, and then we linked the cash to it, created a histogram so that we would see how much money is being spent per month. And then so we could see from this example that float is the biggest tool, like I said in the earlier slides. It's a real big tool to help us use that. So in some ways, float is more important than these actual critical activities itself, because you can't move those critical activities around without having to redo the entire logic of the schedule. So at float, it's the management team's choice as to when the activities happen within their float time, because they have wiggle room to move around. So this really gives a manager who really understands the schedule the chance to fine-tune the project and really manage the cash flow or other resources without delaying the project completion date. Notice the completion date never changed throughout this activity. Completion date of individual activities did change, but the completion date of the overall project didn't change, and so we could still meet a contractual deadline if we still needed to. Okay, so then the next thing from this is to plot a progress S-curve. So it gets the name S-curve because the plot, like we can see here, kind of looks like an S. It's kind of like stretched out S, I suppose. Or maybe if you squint, I'm not sure, but that's where the name kind of comes from. It's kind of flat up here, and then a little bit more curvy in the middle, and then kind of flat again. But anyways, this is called the progress S-curve, which plots the cumulative cost rather than the daily, weekly, or monthly cost, which was plotted in the histogram. So if I go back a couple slides, the histogram is just plotting in a bar chart form rather than the line, but it is plotting it per month. So 22.5 per month, 22.5 per month, 96.1 per month. The S curve is going to plot the cumulative cost, meaning the first data point is going to be 0. Then the second is going to be 22.5. Then the third will be 22.5 plus 22.5. It's adding each individual month together. So it'll be 45. And then 45 plus the 96.1. And then that total plus the 96.1. And then continuing on. So that's what the S curve is. So it went from 0 to the first one was the 22.5, and then so forth. And it plotted those added together. Every month is then added together, so it accumulates. So it's a cumulative cost rather than a daily, weekly, monthly cost. So within that, this curve is generally in the shape of an S, like I said. As the project starts out, there's a slow progress. There's not much money spent in the beginning as things start getting going. Then there's a lot of money spent in the middle of the project when things start to really get off the ground. Then towards the end, there's like less and less money spent. So then that curve gets less steep and more flat. So generally, if this curve starts out usually unusually steep at the beginning, it may be a sign of what's called front-end loading, where the contractor is like overbilling the owner to work off of the owner's cash rather than their own support. and that could be, generally seen as not good practice from the owner, but it may vary on the actual project that's needed. There might be needed more money up front to get going, and then that would consequently mean less throughout the project. Okay, so then within the progress S curve, we're gonna now create the what's called a banana curve. You probably guess, well, the S curve looks like an S. Well, the banana looks like a banana. So how do we get that? Well, we're gonna go back to the bar chart once again. This is the same bar chart from before, but we've moved all of the activities that have float to their latest possible starting date. Remember, K was over the bar for K was over here starting at 3, but month 3, but it had 3 days of float, so we shifted it all the way over so it would now start on month 6, and so forth. We did it with P, we did it with F, and we did it with O, and so forth. So everything's moved to its latest possible starting date. Kind of seems like it would be like a slide bar too, like at 12, the square was connected here, and we just slide it along the line there, just slide over. We would take P, slide that over, and everything slides over. Then the new totals are recalculated. So now the total for month 1 is the same, month 2 is the same, month 3 changed. Remember, it was 96.1, I believe. Now it's 48 because K doesn't start on month 3 anymore, and P doesn't start on month 3 anymore. And so 48 again, now total 48. And you can see there's less money spent at the beginning than it was when everything was shifted at the start. So then we replotted that, created that, and now we have new totals down here. Then from here, if we then plot the cumulative cost like we did with the S curve, meaning 22 would be our first data point, then 45, then 45 plus 48, then and so forth, then we would plot that, and then we plot them together. Here's the first S curve, then here is the bottom part, which we were just trying to plot. Then that creates a sort of banana looking thing where it's kind of closed on the two tips and wider on in the middle. So the first part, we could call that the early dates, where everything is in its earliest position, and then when everything is in its latest position, that would be plotting the latest dates. So this is the banana curve, or you could call it the early date and late date S curves, or something like that, but it's generally known as the banana curve. So this is how we would plot that. We plot these together, which this kind of looks more like a banana than an S curve actually looks like an S. So I could kind of see this too. So within this banana curve, this is like another tool that you could use. We created this before the project has actually happened, and we predict how much everything is actually going to cost, and we create this. Then as a schedule is updated, you would plot an actual progress line in the middle of this. So as this grows, here's what we plot for our early dates, the late dates. Then as project actually starts happening, you would plot maybe like a red line in here. It maybe would be in the middle, or maybe it would be closer right on top of the early dates, and your schedule's perfect. Or maybe on the late dates, and maybe your schedule's a little behind or so. So you could use that as a tool to gauge where you're at in the project. So you'd plot that along, and you would see it growing along, because it's eventually going to take 19 months, and then you would eventually finish. You'd have a third line that would kind of grow throughout the project, and you could use that as a tool to manage the project to see where you're at. And specific information regarding that is that the actual progress line is above the banana, like it's going outside of it. The project is either over budget or ahead of schedule, meaning you're spending too much money, or you're going way faster than you thought you expected, which is also requiring you to spend more money. Then if this line that you're plotting is below the banana, then the project is either under budget or behind schedule. Like you haven't spent enough money, or you're not that far along in the schedule. So then the rule is the actual progress line should be within the banana somewhere. And if the line is outside the banana, then something went awry and you need to manage that. So again, it's like another tool from this lesson that you can use to manage the project. Then now we're going to balance the equipment. The second half of this lecture was to balance those D10 caterpillars. If you haven't looked it up by now, it's a big piece of equipment. So if you do that, it's called an equipment loaded schedule. And so again, the first step is to analyze the number of pieces of equipment that's needed for each activity. Then create the bar chart showing the float and load the bars with the equipment to be analyzed, which you effectively already done when we created the cash flow diagram. Then you examine it and see and then adjust the bars like accordingly. With this example, we're doing these 10 of these pieces of equipment, D8 10 caterpillars, also known by cats because that's the manufacturing brand. That's the big orange ones. I'm sure everyone's seen this in their life before. And so again, here's the same looking bar chart, but again, it's loaded with different stuff. It's not loaded with the amount of money anymore because that would be a cash loaded diagram. So it's loaded with the amount of resources needed, and the specific resources is the caterpillars. So there's 2 needed for W, 1 needed for K, 4 needed for B, and so forth. So the same process. Those are just loaded on here, literally written on the schedule. The total is below here. And then the histogram is created just like from before. Instead of it being total in thousands, it's total of these D8 caterpillars. And then instead of it being in thousands here on our y-axis, it's just the number of caterpillars. Again, we have a situation. It also corresponds to months 4, 5, and 6, which makes sense because that's when the most amount of activity is happening at the same time. B, P, F, and a little bit of O are all happening at the same time. So of course, there's going to be a lot of money spent there. Of course, there's going to be a lot of resources needed there at that time. So there's obviously going to be problems. And then the obvious solution is to make it less congested right here. But you can see that we exceeded the amount of this piece of equipment that we have at our disposal. We go over 10 here by needing 11, and right here needing 12. Again, in this specific example, this piece of equipment is very expensive. It's probably also very expensive to rent, and the operator is probably very expensive and needs specific training. So it's not just trivial to let's just get another one. So we probably want to just stay with our 10, and if we can, we probably want to stay like at 9 or maybe even 8, because what if one operator gets sick one day, has some issues, and can't show up, or what if one of them breaks down, something like that, and so we don't have to whatever go over the amount that we have at our disposal. So then we'll go through the same process like we did with the cash loaded diagram. We'll play around with moving activities around that share float. Move those around to find the best sort of situation. Again, here's the schedule. We can see that K, F, and O, they have some shared float. P and L have some shared float. So something needs to move with them. I've already kind of talked to this. The number of cats needed exceeds that number. So a possible solution is to make area P a predecessor to area F. Because area F and O share float, area O must also be adjusted. And it also just corresponds to the same solution, by the way, for these guys. Even though it's a different resource, like I said previously, there's a lot of action going on right here, so it's probably going to cause problems. So the same solution also works for here. Moving F and O over gets us down to only needing 9 of these caterpillars. So then we have a backup one, just in case, which will probably be safe. So that's basically it. That's how we go through the process. One last thing is, if you are doing this balancing the resources for amount of people, like our crew, then that's often referred to as a labor loaded schedule or a man powered schedule. The amount of people you have available at your schedule at your workplace that you could link to your schedule. And so you can see this as a valuable resource, and using the CPM schedule coupled with a computer you could help play what if. Like, what if we move the schedule around? What if we adjust the float here, and so that we could effectively balance our resources that we have available. The computer default method to automatically balance these resources and putting the schedule in order via the bar chart, like we discussed a couple of chapters ago, again, is the minimum float rule is first order of placing these activities in their order, then the minimum duration rule. And of these two rules, the minimum float rule is probably the most common of moving these activities around. So that's generally it. You can see it's a good tool to balance these resources that you have available for any project to be realistically scheduled. The management team really needs to consider the resources that are used. So it's not practical just like assume you have infinite resources at your availability, and it's probably not even a good idea to just to maximize out certain resources, because eventually you might exhaust them, or something might break down, things like that. So it's a good tool to go through and look through this process and understand, link everything to the CPM diagram first, then create the bar chart and create the histogram, and go through and do this process. So there's a homework for this, and there's actually more of an example of how to do this in Excel. That's in a separate lecture, in a separate file, separate video, that I go through how to do this in Excel first via another example, and then there's a homework. Well, you have to do it on your own and turn it in. It's for both creating a banana curve, a cash flow diagram, and balancing resources, like for manpower, amount of people you have at your availability with the schedule. So there's a whole bunch of givens to it. You just have to go through the process of creating the bar chart and the resource diagram. But I show you how to do it in Excel. That's it.